right, let's jump right in. Today, we're talking about a core concept in object-oriented programming, polymorphism in Java. Now, it's a bit of a mouthful, but the idea behind it is incredibly powerful and, honestly, pretty cool.
So, let me ask you this. Have you ever been staring at some code and seen the exact same method call line for line, but it produces totally different results? It kind of feels like it shouldn't work, right? But it's not a bug. It's a fundamental feature of good Java code.
And that's the puzzle we're solving today. You've got one method name, but it can trigger a whole bunch of different behaviors. This magic is called polymorphism. And in this explainer, you're going to see exactly how it works, using both method overriding and method overloading.
So let's get down to it. What exactly is this thing?
Well, the name itself is a huge hint. It's straight from Greek, poly meaning many, and morphos meaning form. So, many forms. In Java, this means a single thing, like a method name, can take on many different shapes or behaviors depending on the context. It's all about an action having different results based on the object you're using.
Now, polymorphism in Java really comes in two main flavors. We're going to start with the most common one, the one you'll see out in the wild all the time. It's called runtime polymorphism, and we achieve it using something called method overriding.
To really get this, let's just build it. We'll start with a really general or superclass called animal. This class has one basic method, sound, and all it does is print out a generic message. Simple enough?
Okay, now for the fun part. We'll create more specific classes, a dog and a cat. Notice they both use the extends animal keyword. That means they inherit everything from animal. But here's the thing. A dog doesn't just make an animal sound, it barks. So the dog class provides its own specific version of the sounding method. It overrides the original. Same for the cat class. It overrides sounding to meow. And that @override tag, that's not just a comment. It's a signals to the compiler that we're doing this on purpose. It's a great habit to get into.
And boom, here's where the magic really happens. Check this out. We declare one variable, myAnimal, of type animal. First, we make it a new dog. When we call myAnimal.sounding, what do we get? Dog barks. Then, using that exact same variable, we switch it to a new cat. We call the exact same method, myAnimal.sounding, and now we get cat meows. The Java virtual machine figures out which version of sounding to run while the program is running, all based on the actual object. That right there is runtime polymorphism.
This whole process has a fancy name, dynamic method dispatch. As our source material points out, this is the engine under the hood. The method call is dispatched dynamically to the correct implementation when the program is actually executing.
Okay, so everything we've seen so far relies on this inheritance relationship, right? A parent class and some child classes. But what if we want the many forms thing without all that? Is it even possible? Can you have polymorphism without inheritance?
You bet. The answer is absolutely yes. And we do it through a different technique called method overloading.
So let's check out our second flavor of polymorphism. This one is known as compile-time polymorphism, and it's all about that method overloading we just mentioned. Now this works completely differently. With overloading, we're working inside a single class. Look at this MathUtils class. We've got two methods, and they're both named add. So how does Java know which one to call? It's simple. It looks at the parameters. One add method takes 2 integers, the other takes 3. When you write your code, the compiler sees whether you provided 2 or 3 numbers and locks in the correct method before the program even runs. That's why we call it compile-time polymorphism.
Okay, this is a super common interview question and a point of confusion for a lot of people. So let's put overriding and overloading head to head and make the difference crystal clear.
This table nails it. Let's walk through it. Overriding is all about changing an inherited method in a child class, so it happens across 2 classes with inheritance, and the parameters have to be the same. The decision gets made at runtime. On the flip side, overloading happens inside the same class. Its whole purpose is to have methods with the same name but different ways to call them, so the parameters must be different, and the compiler figures it all out before you even run the code.
So if you're ever stuck, just remember this one golden rule. Overriding always involves inheritance. No inheritance, no overriding. Overloading, on the other hand, happens in one class. It doesn't need inheritance at all.
All right, it's your turn to code. Here's a little challenge for you. Go ahead and pause this explainer, open up an editor, and create a bird class. Make it extend animal, just like we did before.
Then override the sound method to make it chirp or tweet. Finally, test it out using an animal variable. Give it a shot.
So what's the big deal? Why do we care so much about this? Because polymorphism is what lets us write code that's flexible and easy to change. You can write code that works with a generic animal reference, and it will just work with any new animal type you add later, like the bird class you just made. You don't have to go back and change all your old code. That is the key to building big, scalable, and maintainable applications.
Polymorphism is a massive pillar of object-oriented design. And in our next explainer, we're going to dive into another one, abstraction. We'll see how it teams up with polymorphism to help you build really complex software by hiding all the messy details. I'll see you there.